When we asked this storyteller about her earliest water memory, she shared that as a member of the free-range children generation, she recalls coming across a woodland spring while exploring with her brother and feeling a sense of magic and beauty in that place. She also remembers returning home for dinner very late that day. Please welcome Julie Stromberg for her story, Small Victories.
So you may not know it by looking at me, but I'm a runner. I have slow twitch fibers that propel me slowly and steadily along. And I have fast twitch fibers that give me the oh so exciting bursts of speed. I also am a scientist and a riparian plant ecologist, to be precise. And I've loved plants for as long as I can remember. And I became a botanist so that I could understand better where plants grow, why they grow where they do, and what they need to thrive, so that I could relay that information to the managers of the water and land. Now, during my tenure at ASU, I focused on the vegetation of desert rivers. Now, the flow in some of these rivers is still free-flowing. The flow in many others has been regulated at dam sites or affected by groundwater pumping in the aquifer. Climatically and historically, these rivers twitched on two time scales too. Let me explain. The fast twitch. In the Sonoran Desert, much of the rain that falls on the land flows quickly over the land surface. It goes into the tributaries and into the big rivers, quickly overtopping the banks, and the vegetation is responding quickly too, the fast twitch, the floods. So my students and I would go out after the summer monsoon rains on rivers such as the San Pedro, Haciampa. We would studiously document the verdant pulses of diversity and productivity, and we reveled as the floodplain came to life with panic grass, scarlet spiderlings, coyote gourds, and others who had lain dormant in the soil as seeds or tubers. And then in winter, after the big scouring floods on rivers such as the Haciampa, we would go out and document the establishment of woody plants. And in March, for example, we documented the Fremont cottonwood seedlings taking root in the moist, bare sediments. And then 2 weeks later, the stream flow declined and the channel narrowed. We saw seedlings of Gooding willow taking root that much closer to the stream, their seeds having been dispersed to the wind that much later than that of the Fremont cottonwoods. What a delicate dance in time and space. What a fine act of accommodation. And then we walked to a drier reach of the river. The Haciampa has a perennial reach interspersed between dry reaches, and we saw seedlings of tamarisk taking root as the young cottonwoods and willows around them died of thirst. So that's the fast twitch, the floods. Let's get to the slow twitch. Some of the rain that falls in the watershed wends its way more slowly to the river. When it falls onto the mountaintop, a raindrop will move into the soil or through a rock crevice, eventually into the aquifer to become groundwater, and then a portion of that subterranean flow will emerge in the stream channel as surface flow. And this process is slow. This is the slow twitch. It can take, for a flood, it can be hours to days before a rain is followed by a flood. For the slow twitch process, it can be decades to centuries before a raindrop makes its way from the mountaintop to the flow in the river. But though slow, this aquifer recharge process is critical for maintaining perennial flow in the rivers during the dry seasons. It's also critical for recharging that floodplain aquifer. So scientists at work, we would head out into the field. We selected wet reaches and dry reaches of rivers. Some had perennial flow, some intermittent, some ephemeral, some had deep groundwater, some had shallow groundwater. And we learned many things. We learned, for example, that wetland plants such as bulrush occur only where there is perennial flow in the stream channel. We learned that those seedlings of Fremont cottonwood and Gooding willow survive only to maturity where the depth to groundwater below the floodplain surface is less than about 10 feet. So we deciphered patterns. So I'm a runner. I'm a scientist. I'm also a compassionate individual who cares very deeply about the plants I studied and still study. Student back there studying a newcomer plant. So as gratifying as it was as a scientist to decipher those patterns and quantify the linkages between hydrologic alteration and vegetation structure and function, there was a lot of sadness. I'm sorry. Whoa. I affected myself there. There was a lot of sadness, which as a scientist during the process, it kind of set that emotional side away. And it's kind of catching up with me in my retirement. anyway, so when you form a relationship with when I form a relationship with a plant, it's very sad to see them lose their home, whether it's a Fremont cottonwood, a Gooding willow, Colorado river hemp, Palmer saltgrass. So there's sadness. But there were many uplifting moments and victories along the way too, and I want to share two of those with you today. The first has to do with a legal victory on the San Pedro River in southeastern Arizona. Now, about 4 decades ago, right about when I was finishing up my dissertation, about a 40-mile stretch of the river was designated as a riparian national conservation area. And with this designation came federal reserved water rights. Now, water law is very complicated, as you well know. Water lawyers spend much time deciphering who among us has rights to how much water and where, and whether it be surface water or groundwater. And when we grant rights to wild ecosystems, that complicates the matter further. I was fortunate to be part of a team that quantified the riparian water rights of the San Pedro River, riparian vegetation, and the fish were involved too. Each component of the ecosystem has their own needs, but these had to be quantified so that they could be defended in court. So we presented our data in a court case a few years back, and then about a year or so later, the Maricopa County Superior Court made a ruling, and they said the water rights for the San Pedro River riparian vegetation, both for surface water and for groundwater, were granted. So I did a little dance of victory. So that was exciting to hear. The San Pedro River, I should say, is not influenced by a large dam, like say the Salt is, or the Colorado or the Bill Williams, but the aquifer has been depleted in area by groundwater pumping. And what this ruling means is that water-hungry development wants to go in. They cannot pump water that belongs to the river. So my plant friends are theoretically protected. Now, the second victory I want to share is a little more personal, and this has to do with my own shift in perception about some of the newcomer plants that grow along our desert rivers. There's a word I'm intentionally not using. You can guess among yourself what word this is. But I've mentioned the plant tamarisk without giving you their backstory. And these tall shrubs or short trees, however you want to classify them, were intentionally imported from the old world to the American Southwest several decades ago. We have our local tamarisk historian sitting in the back row there if you want details. So they were intentionally introduced partly to stabilize, because they were known to be good at stabilizing the sediment, and there were newly built dams with reservoirs, and the tamarisk effectively stabilized the sediment on those reservoirs. But as plants will do, they did not stay put. They moved away from those reservoir edges broadly throughout the American Southwest, where they were not invited. This was uncontrolled, unrequested movement. They did not stay in their locale. And so over time, they went from invited guest to despised immigrant. They've been vilified, even hated, and blamed for allegedly causing a series of ills, such as displacing those Fremont cottonwoods and Gooding willows that grow along the rivers and the abundant bird life they support. But new research flipped the narrative. And we now know that tamarisk, they have deep roots, they produce flowers multiple times throughout the growing season. They have other traits that adapt them for the conditions we are creating along the rivers, be it altered flood patterns, deeper groundwater, grazing of the land by livestock. They have found their niche. So they're not so much displacing the Fremont cottonwoods as replacing them, growing in areas where the others can no longer thrive. They're not so much drivers of environmental change as passengers of environmental change. Sort of fun metaphor. We also now know that and some of this research was conducted by students here at ASU, the tamarisk thickets support an abundance of birds, including a federally endangered species, and their flowers contain abundant nectar that supports pollinators. So they're providing ecosystem services where other plants, in river settings where other plants may not be able to provide them. As a result of this new information, my mindset has shifted, and this is where the personal victory comes in. Once upon a time, This is a story after all. Once upon a time, I despised tamarisk as much as anyone. Full confession. Peer pressure can be a powerful force. People can bond over their hatred of a common enemy. And scientists are not immune. But I now feel compassion and respect and even awe for these plants who tolerate the conditions we create, who can tolerate those altered flood patterns, et cetera, who can tolerate the conditions in which the river is no longer twitching on the historic time scale, to tie us back to those fast and slow twitches. So I still grieve for those who have lost their homes. We need to work as much as we can to restore the physical processes that shape these systems, be it maintaining, securing groundwater flows, restoring flood regimes, that sort of thing. I'm not saying the status quo is great. I'm saying let's work to restore physical processes while respecting those plants, those newcomers, many of whom we invited here. And by embracing these adaptive newcomers, such as tamarisk and many others, as opposed to, say, dousing them with herbicides or using bulldozers, which is still going on. For 7 decades, people have been waging war against tamarisk. By embracing these adaptive newcomers, we allow the ecosystem, we allow the vegetation to provide this range of ecosystem services, be it wildlife, habitat support, the basic one of carbon capture, and mitigating us from the rising heat. Because if we don't embrace these adaptive newcomers and we just continue to wage war, we're only harming ourselves in the long run. So, though I still grieve for the plants who've lost their homes, it's the big finale, I feel lighter on my feet for having set down the burden of hate and fear for immigrants, immigrant plants in this case, and replacing it with understanding and respect. So, to recap, I'm a runner, I'm a scientist, I'm a compassionate individual, and I'm a wannabe dancer, and that last one is clearly a work in progress. Thank you.